Okay, the next part of our lecture for minerals and rocks, we were studying rocks. We studied the two types of rocks. These two types of rocks are the sedimentary, and we said how they are sedimented, and the igneous, and we said all the types of the igneous rocks. Now we came to another type of rock that is very, very strong. Why? Because the origin of this rock is another rock. It's not just for the other material, the origin was not rock or not solid rock. Here the origin of the metamorphic rock is a solid rock, but it is solid rock that increased in the solidifying process to be more strong as a rock. So it is called a metamorphic rock. How metamorphism happens? It either thermal metamorphism, it means that increasing the temperature. I get rock, a type of rock, I subject it to very high temperature, so it changes to be metamorphic rock. Pressure, I take rock, subject it to very high pressure, it changes to be a metamorphic rock. Chemical, rock reacts with the environment around me, so it changes from being a type of rock to another metamorphic type of rock. This is just a simulation for you to understand what is metamorphism. I have clay. If I take a piece of clay, put it in the oven, it will change to be a piece of brick. What is bricks? The bricks that we use to build buildings. How do they do it? They take pieces of clay, put it in an oven, it changes to be stronger, they take it outside, use it as bricks. الطوب الأحمر, red bricks. This is the type of, this is the best type of bricks that we use here in Egypt, which is not anything, not made of cement, just clay in an oven to get very good type of bricks. It is very good in thermal, it does not transmit heat, and it is very good, and it is very strong in the same time. So this is the first part, bricks. If I take a piece of clay, put it for a longer time, it may be a piece of pottery. You know what is pottery? الفخار. They put it longer. So a piece of brick, you see that bricks are very you can break red bricks very easily. But pottery, sometimes you have pottery that is very strong. You can make many things out of this, use this pottery to carry water, to carry, it can carry loads. So pottery is stronger than bricks. Why? Because it was subjected more to temperature. Last thing is porcelain. You know what is porcelain? This is porcelain on the ground. It's very strong. It is stronger. Of course, you know porcelain. It is used in many things. It's used in your teeth. When you go to the doctor, tell you, I'll build a tooth. It's made of porcelain. So it is very, very strong. So how they come to this porcelain? By subjecting clay to more temperature. The same happens here with below the ground. This is just a presentation. This is the rock below the ground. The more the temperature changes, the better the metamorphism that will happen, and the stronger the rock will be. So if I go to this place, this is very high metamorphism, very strong rock. Here is very low metamorphism and very weak rock. This is thermal metamorphism. The next thing is the pressure metamorphism. We can do the same metamorphism, but using just pressure, or maybe pressure and temperature together. This happens where it happens. You remember when we studied the collision of continents and the plates together, and one tectonic plate go below and the other go up, and when the collision happens, there is pressure. The force of the collisions generates pressure. It also generates heat, by the way, but pressure is very high. So when pressure happens, so rock changes to be metamorphic. Just here at this location where the material is going up to go through the volcano. Here, of course, the temperature is low and the pressure is low. So why? Because it is about to meet the ground on top. So no pressure, or the pressure is minimum and the temperature is minimum. But if you go here below, here you have high temperature and high pressure. So here you can have a different type of metamorphic rock. Here you have another type of metamorphic rock. Here at this location you will have low temperature because you are near the ground, but you have high pressure because it is the location where the two continents bumped together, so you have very high pressure. So metamorphism can happen by pressure. Chemical metamorphism is the alteration of the rock by hydrothermal solution coming from magma. So once the magma comes up, some kind of reaction will happen, changing the chemical formation of the material, of the rock. The minerals which compose the rock are dissolved and new mineral formations are deposited in their place. Sometimes some of these minerals decompose and other minerals come from outside and replace this material. So it ends up having another material. This illustration is very, very important. Why? Because it summarizes everything. I also advise you to add it to your list of terms. Here is the igneous rock, the metamorphic rock, the sedimentary rock. These are the three types of rocks: igneous, sedimentary, and metamorphic. As I said, metamorphic was once another type of rock. So metamorphic was once either igneous rock or sedimentary rock. So sedimentary with heat and pressure can be metamorphic, igneous with heat and pressure can be metamorphic. So this is the first glimpse of this photo. All of these three types of rock, igneous, sedimentary, and metamorphic, if they are subjected to weathering and erosion, they can change to be sediments. As we said before, when we were studying sedimentation process, we said that by weathering and erosion, rocks change from any type of rock to be these sediments. And these sediments are, by the way, the start of the soil. If I want to have soil, it is any type of these three types of rock, and it changes into sediments, and these sediments disintegrates to be the soil. So these three types of rock, if subjected to weathering and erosion, they will be sediments. What happens if this sediments is compacted again or cemented with each other? It changed to be sedimentary rock. So if sediments is compacted and cemented by pressure and by temperature and by everything, it changed to be sedimentary rock. So now we have taken all of this. But there is another thing here, which is the metamorphic rock or the igneous rock. It can change, because igneous rocks and metamorphic rock, they can be found at places with very high temperature and pressure. So they can be ejected outside the earth, and if they are ejected outside the earth, the magma go outside and changes into lava. So what happens when the magma changes into lava? Igneous rocks are formed. So this figure is very important, because from this figure, these three together are the three types of rock. These two together are the origins of all rocks. It is either igneous or sedimentary. If they are subjected to heat and pressure, they are metamorphic. If the three disintegrates and weathers, and by weathering and erosion, it changes to be sediments. If the sediments are compacted and cemented, they change to be sedimentary rock. If metamorphic rock melts or igneous rock melts and is ejected outside of the earth, then it changes into magma, and the magma is ejected outside of the earth, and it changes again into lava, then to igneous rocks. So this chart helps you to understand the relation. This is called the rock cycle. The rock cycle, it means that all of the rock that we see around us can change to be another type. There is, if I see anything of the material of the soil, it was not the same millions of years ago. It was another thing. So it was another thing. It was changed through this cycle to be this other thing. This is the same cycle, but instead of putting it into a cycle, we just put it into a presentation of the ground itself. Here is rock. If it is affected by weathering and transportation, it will disintegrate. And if I have magma below, and this magma changes to be igneous rock, then this igneous rock is uplifted to go through the volcanoes and outside. It is a little bit, here is sedimentary rock. It is a little bit it's not as simple as this one. I prefer this one because it gives me the relation itself. I can see the relation. I put material that are similar to each other next to each other so that I can understand easily. But here, this is how they are formed in the nature itself. So, both are okay. Both are called the rock cycle, but this is a little bit complicated. This is the sedimentary, this is the igneous, this is the metamorphic. Sedimentary and igneous can change to be metamorphic. Everything that is shown here is shown there, but it is shown in the natural way that they are found in the nature. Also, this is another rock cycle, but I prefer the first one. What is important here, that they tell you all rocks can change into other types of rocks. There is no stagnant type of rock. I cannot say that this rock was the same millions of years ago. Sedimentary can change to be metamorphic. Metamorphic can change to be igneous, and so on. This is a cycle of rock, but I also prefer the previous one. Last thing in our lecture is the geologic map. What is a geologic map? We said that we have now we have studied lots of material here. We have igneous rock, metamorphic rock, sedimentary rock, and then they change to be sediments, and these sediments change to be normal soil, and sometimes the metamorphic rock changes to be magma, and magma changes to be lots of types of rocks. Where can I find these? Yani, this is a presentation. I want to, if I am going to build a project in Alexandria, do I expect to find igneous rock, metamorphic rock, sedimentary rock? I don't know. So scientists help me by doing something called a geologic map. A geologic map is something that, using color code, they color the ground and give you some indication. This yellow means something, this blue means something, this green means something. Every map has a key for this map. When you see that I'm going to a site at this location is the blue type. I go to this blue type and see what is the expected formation. But does this mean that it is accurate? No, it is not accurate. It is more or less reasonable, but it is not accurate. It means that I may be working at this place and they tell me that you will find this specific type of rock, and at this specific location I go and I don't find this rock. Why? Because the formation changed in this rock. There are many other factors that affect, but if I cover all of these blue areas, 90% of them will be correct and 10% will not be correct. So it helped me in expecting what to find, but it does not give me a very accurate data. I'm now going to make a building in the desert. I will have to travel 100 kilometers to reach my site. I want to do a site, usually I should do site investigation, this is sure. What tools should I take with me? I don't know what I'm going to find. So if I study this geologic map, the geologic map will tell me the expected formation. So if I know the expected formation, I cannot take with me everything. Maybe I have to travel very long distance in the desert. I cannot just carry the whole lab with me. I will take with me the tools that I expect to use, especially if these tools are big, heavy. I cannot just carry all of them with me. So I will carry whatever is expected to me, that I will need. So in this case, I will use the geologic map to help me to find what I expect to find. When I know what I expect to find, then I can do a site investigation. The number of boreholes, if I go there and I do boreholes, and these boreholes were in accurate confirmation with the geologic map, then I don't need to make other boreholes. But if the geologic map say that you expect to find sandstone, and I go there and I find another type of an igneous rock, so there is a difference. Then I have to increase the number of boreholes to check all locations, because maybe this is in just one spot, maybe in the other spot it is different. So it helped me to define the amount of investigation that I will need. So it helped me to expect, it helped me to confirm. So if it confirms, then I can reduce the amount of the site investigation, reduce the money that you are going to spend, the time that you are going to spend, and take the information. So it helps you to confirm or to expect whatever you are going to see when you go to your site. So geologic maps are very important for us. especially that they are found this is you have a map for the whole world, you have a map for Egypt, you have a map for Cairo, you may have a map for specific areas, it will be more detailed. So if I want to go to a site, I will bring the map with the best details, I will use it. If it confirms, if I go and perform the site investigation and the site investigation confirms what I expect, then it is okay, this is fine with me. If there is a contradiction, then I will have to increase my site investigation a little bit, add more boreholes, take more samples, so that I can prove that the formation is okay. So geologic map, you will have a lecture for geologic map. Dr. Serwa is going to give this lecture to tell you how to read the geologic map. We said that there is a geologic map, and we said that it has a color code and so on, but how to read it, how to understand it, this Dr. Serwa is going to give you a special lecture for this topic, so that you can know. Of course, geologic maps are not included, the concept of geologic map may be included in your exams, but how to read a map, this is something practical that you need to understand in this lecture. This ends up our lecture. Thank you. Before I leave you, I just tell you that in this lecture we were studying minerals and rocks. We concentrated on the part from minerals and rocks that will be interesting for us as engineers. We minimized lots of data that is not relevant to our engineering work, and we concentrated on the data that will help us in our geotechnical work or even any civil work in future. Thank you, and see you next lecture.